In this video, we will be doing the following problem. The polygons below are regular, meaning all sides are congruent. Are all of the diagonals within each one congruent? So now remember, a regular polygon means all sides are congruent, they're equilateral. That also means they're equiangular. Equiangular does not necessarily mean equilateral, but equilateral does mean equiangular. So let's start with the triangle. Well, this is sort of a trick question because there are no diagonals in a triangle. Next, we go to the square and we remember all sides are congruent and then opposite sides are parallel to one another. And then all angles are right angles and are therefore congruent. Next, we will draw our two diagonals right there and right there. And you'll notice here we have two congruent sides and a right angle in between. And then over here, we have two congruent sides and a right angle in between, meaning these two diagonals are in fact congruent. And there are only two, so that's it for a square. Now we move to a regular pentagon. So all sides are congruent, and then all angles in a regular pentagon are also congruent. Again, remember, equiangular doesn't mean equilateral, but equilateral does necessarily mean equiangular. So now we will draw a diagonal here and here. So with these two diagonals, we have congruent angles in the middle, and we have two congruent sides on each side of that angle. So by SAS, both of these are congruent. Now, if we draw more diagonals, there and there, you can see that each diagonal has the same two congruent sides and the same congruent angle in the middle. So by SAS, all diagonals in a regular pentagon are congruent. Next, we will move to the hexagon. So again, this is a regular hexagon. So all sides of a regular hexagon are congruent, and then all angles in a regular hexagon are also congruent all the way around the hexagon. Now let's start with a diagonal here and a diagonal here. You'll notice this side is congruent to that side, is congruent to that side, is congruent to that side, and we've got this angle congruent to that angle in the middle. So yes, these two diagonals are congruent to one another. However, now let's draw this diagonal right there. You will notice the sudden appearance of a circle around the hexagon. So the circle is circumscribed about the hexagon. This is to prove that these two diagonals are not congruent because you can see this diagonal is the diameter of this circle. And then this is not going through the center of the circle. It is not a diameter. Therefore, it is a shorter chord of the circle. Therefore, these two outer diagonals are congruent to each other, but they are not congruent to this middle diagonal. And you will find that any polygon with a side number n equals 6 or greater does not have all congruent diagonals. So to recap, regular triangles do not have diagonals at all. Diagonals to squares and pentagons are all congruent, but starting with hexagons, any polygons with n equals 6 or greater will not have all congruent diagonals. You'll have some diagonals that are congruent to others, but they're not all congruent. We will not be doing a formal proof for anything beyond n equals 6, but so you can see the thought process. For higher polygons, you can see we can circumscribe a circle around each one, and then I can draw this line here. It does not even have to have a diameter. You can see if I draw more chords around the circle, which would correspond to more diagonals for polygons with higher numbers of sides, they get shorter and shorter and shorter as we go. For a square, there's only one from each vertex. For a pentagon, there's only two for each vertex. Starting with a hexagon, there's three, and then more and more and more as we go. So that is the thought process so that you will know for n equals 6 and beyond, not all diagonals will be congruent. As always, work through it 3 or 4 times. You will get it.